Alright, hi everyone. Alright, so let's just kind of talk real quick about what the rest of the week looks like. So today we're going to be talking about a second day of solving radicals, so day 2. Tomorrow we're going to talk about our last day of solving radicals, so day 3. There's only a couple of solving radical problems in your homework over the weekend, but there'll be a lot more tonight. On Wednesday, we'll talk about solving systems. Those systems will be equations that are radicals as well as rational, so it'll be a good review of the last 5 days. And then we'll have another day of it on Thursday where we start talking about some application questions and word problems and setting up systems. And then on Friday, we will review for the test. Monday, we don't have any school. Tuesday, we'll review for the test. And then Wednesday, we'll have the test. So we have a lot of review time. You have the weekend, which is great. So just make sure that you're here on Friday to get the test review. If you're not here on Friday, make sure that you grab it offline or something like that so that you can start working on it. Okay? And then I just wrote out here the rest of the week. I have on the calendar that there's a 10-minute quiz on this day. It's not going to be tomorrow. It's not going to be on Tuesday. It's probably going to be on Thursday, but I will let you know for sure on Wednesday. It's gonna be short. It'll be like 2 questions. Okay. All right. So I have on your warm-up these 2 problems. It would be best if you guys actually try to do these 2 problems and then check your answers instead of watching me do it, since it's review anyways. Okay? So assuming that you've paused this and you're done with it, let's check your answers. If you look at your denominators, your LCD, notice that this fraction has a 3. Notice that this one has a 3, so then you can make your other one have a 3. Notice that this one has the 2 binomials of x plus 5 and x minus 1, and so does this one. So then you can make them all have x minus 1 and x plus 5. Okay, so then that's my LCD. When I distribute it to here, my binomials will cancel, leaving me with my 3. So I'll get 1 times 3, which is 3. When I multiply it by this fraction, the only thing that cancels is my 3, leaving me with 1 times both of those binomials. So I'm actually going to multiply them out. I get x squared plus 4x minus 5. I bring down my plus sign. When I multiply this, everything cancels, leaving me with a 5x minus 2. So I can see that this is x squared, so I want to get everything to the right side. I have x squared. Let's see, I have 9x and negative 5, that's negative 7, and I have to subtract 3 over, which makes negative 10. So when I factor this, I get a 10 and a 1. This has to be positive and this has to be negative, so I get 2 x values, one of which is negative 10, and then one of which is 1. If I look back at my denominators, I cannot have a 1 because of that, and that's it. This one tells me that I can't have a negative 5, and then that's it. So this one is a solution. X equals 1 is an extraneous solution, and you should be showing that you get it and crossing it off, which identifies that it's extraneous for me. Okay? And B, we have both radicals on each side, which is good. That's what we want. So by squaring both sides, we actually get rid of the radicals, and it just leaves me with 3w minus 8 equals w plus 4, and I get a pretty simple linear equation. I subtract w to the left, I get 2w equals 12, so w equals 6. And make sure that this works. You have to actually go back and substitute in and show me. So 3 times 6 is 18 minus 8 and the square root of that. And then 6 plus 4 is 10 and the square root of that. So without a calculator, I don't know what the square root of 10 is. However, the left side is 18 minus 8, which is 10. And the square root of 10 equals the square root of 10 no matter what the decimal answer is. So this is the solution. Alright, so let's talk about some more radicals. I have 6 problems for you. If you think that you can do any of these before I go through and explain them, it would be good for you to try them first, and then you can go back and listen to me explain them. Alright, so, number 1, in order to get the radical, I want to get the radical by itself, so I subtract 3 to both sides. Oops. Minus 25. Subtract 3, I get a 2. I want to square both sides, which gives me 4. Add 25 to both sides, I get 29. If I check my answer, 29 minus 25 is 4, so square root of 4 plus 3 equals 5, so 2 plus 3 is 5, that's good, so this solution works. Okay, let's try again. Cube root, same thing as a radical. I want to get it by itself. Again, go ahead and try this by yourself first, and then pause it. You can check your answer. I add 4 to both sides. I get the cube root of x equals 4. In order to undo a cube root, I cube. So I get that x equals 4 times 4 times 4 is 64. If I go back and check my work, cube root of 64 minus 4. So the cube root of 64 means what times itself? 3 times is 64, which is 4. 4 minus 4 is 0. So that works. Okay, let's try another one. Alright, my goal when I have a radical is to get the radical by itself so I can undo it. Sorry, this is jumping all over. So, in order to get the radical by itself, I want to add 3 to both sides. So I get x plus 3 equals the square root of 4x plus 12. Alright, I want to square both sides. This will get rid of the radical. Make sure you square the whole quantity. Remember that this is addition, so in order to get the right answer, you cannot distribute. You will miss the middle term. This is saying x plus 3 times x plus 3, so expand. That gives me x squared plus 6x plus 9. If you expand, you lose that 6x, which equals 4x plus 12. I can see that this is quadratic, so I have to set equal to 0. I have x squared plus 2x minus 3. Let's see, factor. I get 2 solutions, one of -3 and a 1. I need to go back and check my answers. Alright, let's see. So if x is -3, this is going to be -3 equals -3 plus -3 times 4 is -12 plus 12, square root of this. And then actually I'm going to go rewrite the other one too. So if I have a 1, that would be 1 equals -3 plus the square root. Let's see, 4 times 1 is 4 plus 12. Okay, so let's go back and check. -12 plus 12 is 0. The square root of that is 0. -3 plus 0. So this one is good. It works. And this gives you 16, which square root of that's 4. -3 plus 4 is 1, so that works too. So both of those are my solutions. They both satisfy the equation. Alright. This would be a good one for you guys to try on your own. Unpause it, check your answer, but get your radical by itself. Okay. So let's check your answer. I have 3 and the cube root of 16x. I'm going to add that 7 to the other side, which gives me a -6. I'm going to divide by 3, which gives me -2. In order to undo the cube root, I cube, so I get 16x equals, you're doing -2 times -2 times -2, so you get a -8. Divide by 16, x equals -1/2. Be careful, guys, that you actually write out that you're dividing by 16. It's very common to see those two numbers and say -2 because we divide in the wrong order. Okay, oops, sorry, I don't want to assume that this answer is right. I'm going to check my answer. 3 cube root of 16 times -1/2 is -8. Minus 7, and I want to know if that equals -13. So the cube root of -8 is -2, times 3 is -6, and -6 minus 7 is -13. So this is a solution. Alright, let's try again. Sorry, this is jumping all over the place. Okay, next one. We have, very similar to the problem that we just did up above, or actually in the warm-up. Instead of the square root of both sides, we have the cube root of both sides. We have it on both sides, so that's where we want it. So when we cube this side and we cube this side, it just undoes both of them. So I'm left with x plus 4, which equals 2x minus 5. So I get left with a pretty simple linear equation. If I subtract x to the right, I get x equals, and add 5 to the left, I get x equals 9. Those are nice quick problems. So 9 plus 4 is 13, and the cube root of that. I want to know if that equals 9 times 2 is 18, and 18 minus, I'll just write about 18 minus 5, and the cube root of this as well. Again, the cube root of 13 is not a nice number, and I really don't care what it is, because this also is the cube root of 13, which means whatever the cube root of 13 is, it's obviously equal to itself. So this works, which means this is a solution. Alright. This one's going to take a little bit more work. This would be a good one for you guys to try on yourself, and then again, go back, come and see how this works out. Okay, so assuming that you are watching it now after you've at least attempted, let's go through this. You have two radicals. You want them on both sides, not the same side. So I could move either this whole term over, but then I'd have to subtract it, or I could move this whole term over, and then I get to add it. So I'm actually going to move that one over because I want to try to have things positive if I can. So I have this 6 times the square root of x equals the square root of x minus 1. Okay. Since I have the radical on both sides, I'm going to square both sides. Notice that I'm squaring the whole quantity. On the right side, that radical is going to get undone. Now, on the left side, since this is 6 times the square root of x, I can distribute it to both. It is not 6 plus, so I don't have to expand. 6 squared is 36, and the square root of x squared undoes it, so now it's 36 times x, which equals, on the right side, that just undoes the radical and leaves me with x minus 1. Okay, so I subtract x, I get 35x equals negative 1. Divide by 35, and I get that x equals negative 1 over 35. Okay, I go back and check my work. I have 6 radical of negative 1 divided by 35 minus negative 1 over 35 minus 1 radical of this, and I want to know if that's going to equal 0. Okay, this one you kind of have to use your calculator for, so I'm going to bring my calculator up. Let's see. Oops. Alright, so when I put in my calculator, I want to be careful how I put it in. I'm going to have 6, and then the square root of negative 1 divided by 35. And so here's the thing, we really didn't need to use our calculator because my calculator can't do this anyways. So notice it says non-real answer. So because it says non-real answer, I guess I could have stopped before this and recognized that this can't happen, and neither can this because they're both negative numbers. So then this is not a solution, which means that my answer is no solution. Alright, so that should be a couple more problems than with radicals. Your homework tonight is just to complete half of your worksheet. It's actually long just because I kind of mix and match the next 2 days. I would try to complete at least half of it. Feel free to complete more because then it's less homework that you have to do tomorrow night. But yeah, I mean, here's a bunch of solving. So you're going to have radicals. So all these are solving, some radicals, some rationals. On this page, you can see that you have radicals. Some of them are going to be longer, some of them will be shorter. I try to give you guys plenty of room. Same thing on this page. So there's 3 pages of solving, but there's only 4 problems on each page, so it's not that many problems. I just try to give you as much room as possible. It does take time by the time you write out your algebraic steps, by the time you check your answers, all that. Okay, and then I did put the last page, which is review, so some order of operations, some adding, multiplying, dividing, some subtracting, and then some complex fractions. Okay, and then tomorrow we'll talk again about pretty much everything. Tomorrow's notes will look like this, so some review. Okay? Alright, I will be back tomorrow. If you guys have any questions and you want to come see me tomorrow morning, I will be available. I'll be here about 7:15. Alright, thank you.